There are 7 models that can currently take control of your computer through an API. Most people have no idea this exists. This is the Claude Computer Use masterclass. I'm going to show you exactly what it does, what the real limitations are, how the safety guardrails work, and how to set up a safe environment to run it yourself, all from the official Anthropic docs, published November 2025. Step 1. What computer use actually is. Computer Use is a beta tool that gives Claude the ability to see your screen and control it. 3 primitives: screenshot capture, mouse control, and keyboard input. That is the entire system. Claude takes a screenshot, decides what to do, clicks or types, takes another screenshot, and repeats. It is a perception action loop running in your application. Source document docs.anthropic.com. The key thing to understand is that Claude does not run this tool directly. Your application runs it. You build the loop, Claude decides, you execute. That distinction matters for both safety and architecture. Step 2. Which models support it? As of August 2026, the current beta header is Computer Use 2025-1124. This header unlocks computer use on Claude Opus 5, Claude Sonnet 5, Claude Opus 4.8, Claude Opus 4.7, Claude Opus 4.6, Claude Sonnet 4.6, and Claude Opus 4.5. Source document docs.anthropic.com. There is an older header, Computer Use 2025-0124, which covers Claude Sonnet 4.5, Claude Haiku 4.5, and a few retired models. If you were building today, use the new header. One important performance note from the docs: Claude Sonnet 4.6 is more mechanically precise at clicking than Claude Opus 4.6. Claude Opus 4.7 narrows that gap. Model choice affects accuracy, not just cost. Step 3. The token overhead you need to plan for. Computer Use is not free to run at scale. The beta system prompt adds 466 to 499 tokens automatically. Each tool definition for Claude 4.x models costs 735 tokens on input, and every screenshot you pass to Claude is billed at the standard vision pricing rate. If you run 100 iterations in an agent loop, you are paying for 100 screenshots on top of all the text. Source document docs.anthropic.com. This is why most production computer use deployments use Claude Sonnet 5 rather than Opus 5. The mechanical precision is close enough, and the cost difference is significant when you're doing hundreds of actions per task. Step 4. How the safety guardrails actually work. Anthropic has built it 2 layers of defense against the most dangerous attack on computer use agents: prompt injection. Prompt injection is when malicious text on a web page or inside a screenshot tries to override your system prompt and redirect Claude's actions. Layer 1, training. The model has been trained to resist these instructions. Layer 2, classifiers. When you use the computer use tools, classifiers automatically scan every screenshot for potential prompt injection content. If they detect it, Claude automatically stops and asks for human confirmation before continuing. Source document docs.anthropic.com. This is not optional. It runs by default. If you want to disable it because you're running a fully automated pipeline without a human in the loop, you have to contact Anthropic support directly. Step 5. The 4 guardrails you must implement yourself. The safety layer Anthropic built only covers prompt injection. The other risks are yours to manage. The docs are explicit on 4 required practices. First, use a virtual machine or container with minimal privileges. This limits blast radius if something goes wrong. Second, do not give the model access to sensitive data, like passwords or financial credentials inside the prompt. If you must authenticate, use isolated credential managers inside the container. Third, limit internet access to an allow list of domains. This prevents an agent from being redirected to a malicious site that injects harmful instructions. Fourth, require human confirmation for any consequential action: financial transactions, accepting terms of service, form submissions. These are not suggestions. They are the documented minimum for safe deployment. Step 6. What it cannot do reliably right now. Honesty matters more than hype. The official limitations as of August 2026: latency is real. Computer use is slow compared to a human operating a computer directly. Coordinate accuracy can fail, especially on high-resolution displays where screenshots get downscaled. Retina displays on macOS capture at 2 times device pixel ratio, which shifts all the coordinates unless you compensate. Complex spreadsheet operations may require multiple attempts. Social media account creation is explicitly limited, and niche applications or multi-application workflows have lower reliability. None of this means it is not useful. It means you need to scope your use cases to tasks that tolerate imprecision and can recover from errors. The payoff. You now know what computer use actually is, a perception action loop, not magic. You know which models run it, what it costs in tokens, how the safety layers work, and exactly what the current limitations are. The operators building with this today are not waiting for perfection. They're building scoped, supervised agents for repeatable tasks where the cost of imprecision is low. If this is the kind of infrastructure knowledge you want every week, subscribe and follow along. All week we go deeper into computer use.